So this is an introduction for PLC-1 IA208, just describing how ladder logic works. Ladder logic was created by electrical engineers who didn't have a lot of imagination, because all they did was created a programming language based exactly on how they were currently doing their logic circuits using old-fashioned relays. So ladder logic is just like a wiring diagram. It operates like a wiring diagram. And it's done by these old school electrical engineers. It's somewhat limited compared to modern programming languages, and that's why you start to see more and more new languages available in PLCs. But it's still a really solid language. It's still probably the most common, and it's extremely useful. They've expanded this wiring diagram concept, but the basic concept is still old-fashioned wiring diagrams. We have a wiring diagram called a ladder diagram. All right, and we're going to describe how that ladder diagram works and how the electrical circuit works, and then we're going to talk about how ladder logic programming works. So let's get started here. I'm going to flip my camera to my desk cam. So in a ladder diagram, you always have two things. You've got a rail on the left and a rail on the right. And generally speaking, you say the rail on the left is plus and the rail on the right is minus. Or you might say this is hot and this is common. But in our case, we're going to assume this is DC voltage, and we're going to pretend that we've got a battery with a plus and a minus, and that that battery is hooked up to that rail. So now I know I've got plus, say, 24 volts. We'll just assume this is a 24-volt battery. I know that's not your standard D cell. It's a very special battery. Plus 24 volts here and 0 volts here, or the minus there, okay? So if I wanted to wire up a light, say I had a little 24-volt LED light, I would basically run a wire over to this light and put it into the plus side, and then the minus side and hook up to the other side of the light, and my light would turn on. Now, in a wiring diagram, that light has this very special symbol telling me that it's a light. It's an indicator lamp. And I would often put the color of that light in the little circle to say it's a, say R is usually red light. And then I would always label that. In this case, I'll label it indicator lamp 1, to say what label I would give that object that I need to wire up that way. In a wire diagram, I would also put wire numbers, but I'm not going to use wire numbers in this case. So this is a very simple wiring diagram. Now, if I wanted to have a light that would turn on when I throw a switch, this is the very basic logic. Then I would draw a switch symbol. This is a normally open switch. And then I would draw the lamp symbol. Say this is going to turn on a green lamp. So that in my wiring diagram means if I throw that switch, then this circuit's closed. Then the plus flows into the indicator lamp, and then that indicator lamp has wired up to the other side of it, the minus. So now that green indicator lamp will turn on. When I flip the switch off, then it goes off. So that is your very, very basic logic. So in the PLC program, right, if I have an input, I can hook that up to a generic, normally open bit. And then I can have that hooked to an output, which would then be hooked up to my energized coil. So now when my input is turned on, I link that to that switch, that normally open contact. And then that will now cause that output to turn on, which I link to my indicator lamp. Now that is your first basic logic for, but the important part here is I need to hook this to that switch somehow, or to a push button, right? So I will give it an address, right? And we'll learn about addressing in a second. So I need to link that to an input. Because if you remember way back when we talked about what makes the PLC is it has inputs and outputs. And so when I wire up an input, depending on what screw I use to wire it in, that tells me what its address is. And then all I have to do in here is say, all right, link to that address to get that information. When that information is saying that input's on, then this will turn on that output. And this one needs an output address. And that output address, then we'll turn that one on. And that is how basic PLC ladder logic works. This is your first exercise that you're going to be doing as part of your homework. So let's talk about one more thing. You guys have done motors and controls, right? And in motors and controls, we have something called a latching circuit. Now, a latching circuit is one that relies on a very particular device. It's called a motor starter. And that motor starter, let me look at my terrible diagram of motor starter, has a coil. I should label that. And when you apply a voltage across that coil, it gives you a magnetic field which causes this pin to pull down or push up. And when that pin pushes up, it causes the voltage coming in from your line to go into your motor. All three contacts are your three phases for your three-phase motor. In addition to those three contacts, this motor starter has got an auxiliary contact. So I could use that auxiliary contact for other purposes. And the way I'd use it in a motor starter circuit is when someone has a push button, it'll turn on that contactor. In other words, that motor starter coil is energized and the contacts are closed and the motor starts running. When I release the push button, if I didn't have this, then that motor would just turn off. But because I have a contact in there that's an aux, then when it turns on, as soon as I start the motor running, then when I release my push button, this stays on and the motor stays running. But what's the problem with this circuit? Anybody? Well, the problem with this circuit is there's no way to turn it off. So in order for me to turn this off, I need to have a contact here, which would be a normally closed push button. And so that when I press that push button, it opens up the circuit, turns off the motor, releases the aux, and then when I release that, it closes again, my motor stays off. That's called the latching circuit, and it relies on a very special feature, which is an aux contact in a motor starter. We can do the same thing in PLC programming. All right. In PLC programming, I can have a start push button that's wired into one of my inputs, a stop push button that's wired into another input, and an aux contact who has the same address as the output for my motor starter. So when I turn this on, it latches the motor starter on, and that address also latches the aux on. So now that one indicator, when the green line is when I first fire it up. Once I release the start button, then the red stays on and keeps that motor running. called the latching circuit until I press the stop button. Then that releases and the motor stops.